Howdy, y'all! Today we're gonna do 2.5 Reasoning and Algebra and Geometry. Yeehaw! Alright, let's get down to business. So the first thing we're going to talk about is what the word justify means. When I say justify, I'm basically just explaining what I did and like why I was allowed to do that. So a lot of times I'll say, what's your justification? So you just tell me why you did what you did, or justify what you did. You're explaining what happened. So you need to know that. Just a reminder, anytime if I'm going too fast, please pause the video, obviously, or rewind it, and just take down any notes, like what the properties are. I'm going to start you guys off with a quick review. I'm not going to talk a whole lot about these properties, but you do need to know associative and commutative properties. Each one has there's properties of addition and multiplication. So when we say commutative property, that's basically just switching around the pieces. And when I say associative property, I'm grouping them differently. So the first one, 3 plus 7 equals 7 plus 3, those are obviously equal because 10 equals 10. All I do is switch those pieces around. That's going to be the commutative property of addition, because I'm obviously adding and I just switched around the pieces. 12 times 4 and 4 times 12. Same thing, I'm just switching them around, but this time I'm multiplying. The next one, I'm multiplying, but I'm grouping them differently. So that's going to be associative. And the last one, I'm grouping differently, but this time for addition. Okay? I normally don't get too nitpicky on properties. If you just say associative, if you don't specify addition or multiplication, then I'm not going to fuss over that. Okay, so other properties that you need to know. You might want to write these down. They're pretty self-explanatory. It's up to you. The first one is addition property. Excuse me. Okay, so what you want to do is, if you have two pieces that are equal to each other, so like A equals B, if I add something to both sides that's the same piece, if A and B are already equal, and C is obviously equal to itself, and I add that piece, then it's going to be the same thing. So in other words, I guess, let's say I have a statement like, let's say x equals 5, okay? And then if I take something, the same number, and I add that to both sides, and add 2, then they're still going to be equal, okay? Same thing, I'm going to move a little faster now, so same thing for subtraction. All I'm doing, subtraction property means I subtracted on both sides, multiplication, multiply on both sides, division, divide on both sides. Hopefully y'all know what substitution means. Go to Wendy's and you don't want those fries, you want a baked potato, you substitute. When you substitute something, it doesn't mean that you get both things. It means you take one thing and replace it for the other that have equal value. So in math, a lot of times you might say like A equals B. And so if I have a statement that says, 3A, well then I can also say 3B if I know that A and B are equal. Okay. Write this down for sure. Definitely important. Definition of congruence. This is something that we're going to use. This will be one of our justifications. So this might be a reasoning that we'll use later on. Anytime you go from equality to congruence, or vice versa, congruence to equality, this will be your reasoning. Okay, so what I've done here is, on this first example, I have been talking about the measurement of angle ABC is equal to the measurement of angle DFG. Whenever we're talking about angles and equality, we put the M out front because we're talking about the measurement. When I'm talking about congruence, I'm talking about the actual angle. So let's say if I were, doing something and I wanted to justify, why I went from this step to this step, my reasoning would be definition of congruence. Same thing down here, I'm talking about a segment going from congruence to equality. My reasoning is still definition of congruence, because that's what congruence means. If two things are congruent, then they're equal. Alright, some properties that you need to know. For each of these properties, we have these properties for equality and congruence. Okay, so if you're dealing with the equal sign, the equality property. If it's congruence, then, congruent sign, then it's congruent. So reflexive property, the idea is that something equals itself. So if you think about a reflection in the mirror, like the cute little kitty here, oh, meow, meow. Of course, she's not as cute as my cat, but anyway. Then if it's something equals itself, then that's reflexive property. So that reminds me a lot of like a reflection. You see yourself. So reflexive property, something equals itself. So we have this for equality, and we have this for congruence. Notice just some notation. We've talked about this before. When we talk about equality, we're talking about the measurement, so there's no line. Talking about congruence, I put the symbol above it. Again, measurement of an angle, congruence of an angle. Next one, symmetric property. So this is a little bit different. It's going to be like an if-then statement. It's two separate pieces, and then you can switch those pieces around. So for example, if A equals B, then B equals A. I switch those around. If W plus 13 equals 20, then 20 equals W plus 13. So that's symmetric property. For congruence, same thing, but it's two separate pieces. So if AB is congruent to CD, then CD is congruent to AB. If A is congruent to B, then B is congruent to A. So you're switching those around. They're switching places. Hi now. Okay, so make sure you're writing that down. Transitive property. So this is the one, I think I mentioned this the other day when we were talking about syllogisms. So you got a little train, chugga, 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 woo, woo. Yeah, so anyway, you have transitive property of equality and congruence. So this is a lot like syllogism. You're going to see some repetition. So notice on equality we have if A equals B and B equals C. If these are the same, you kind of get rid of that and you go straight from A to C. Same thing over here for congruence. Angle A is congruent to angle B, and angle B is congruent to angle C. Therefore, angle A is congruent to angle C. That part just goes away. Make sure you write that down in your notes. Alright, so some properties. These are some examples. We're just going to say which property we used. So if you want to pause it and you want to try them on your own first, that's fine. If you want to just go ahead and do these with me, that's fine as well. So, here we go. The measurement of angle A equals the measurement of angle S. And the measurement of angle S equals the measurement of angle K. Which property does that remind you of? Well, I sure hope y'all said transitivity, because we have some repetition here. It goes from S to S, so you get rid of that. So this is the transitive property. Okay. Next one. Okay, we've got 3x plus 7 equals 23. Then we go to 4x plus 7 equals 23. What do? We combined like terms. So some of these, I really didn't talk about. If these pieces are already equal, and you just combine some like terms, they're still going to be equal. So there's a couple of things you could put here. When you are doing your proofs, if you were going from this step to this step, I would be perfectly happy with you putting something like simplify, or how did we get to do that simplification? We added. Okay, so you could put addition property if you want to get all fancy on it. So I'm fine with either thing like that. If you're combining like terms, simplifying, just tell me what you did. Okay, I added, so it's the addition property. All right, last one. How did they get from here to here? Well, by George, it looks like they might have subtracted the 5. Okay, so that's what they did. This is subtraction property of equality. I'm just going to put subtraction property. Okay? If you want to abbreviate, that's fine. Just watch out with abbreviations, like on subtraction and substitution, because they both obviously would have SUB. Alright, so almost finished. I'm going to show you a proof. A proof just has the work on one side, and then it has the reasons on the other. So your justifications are over here. All I'm going to do is say what happened. Your first step, when you're given a problem, where did it come from? You didn't make it up. It came from somewhere. It came from the given. Okay? It was just there. So I'm going to put given here, because that's where it came from. Here's 5x plus 1 equals 21. What do you know? 5x plus 21 up here by the given. However, you never ever use prove as a justification. Don't do that. I will go nuts. Okay, so the next thing is, from here to here, what did we do? Hopefully you're thinking that they subtracted. So it's subtraction, property of equality, and finally they divided. So just put division or division property. I don't care. I'm not too picky when it comes to your justifications. As long as it's right, I don't care if you want to abbreviate a little or if you want to, I'm not going to nitpick if you put congruence or equality. Just put the main idea. If you added, put addition. If you subtracted, put subtraction. Alright, so move on to one a little bit harder. Go ahead and add this to your notes, and whenever you're ready, you can play it and I'll go through it. Or if you just want to sit and absorb, it's up to you. So the first thing was given. That was in the problem. The next thing, AC plus CB equals AB. What are we doing? Well, you are adding segments. So this first one is the segment addition postulate. Okay? That was like one of the things we did, like the first or second day at school. Talked about segment addition postulate. We know that this piece plus this piece equals the whole thing. How did they get from here to here? Where did they get this info from? They got it from the problem. So what did they do? They substituted. Okay, substitution. Get how hoity-toity there and do property. Sounds fancy. Alright, and you always say what you did like after the fact. So by this point, it's already been substituted, so that's what I put over here. So from B to C, what happened? What happened? Okay. And I haven't talked about every single little property because a lot of these things are things that you already know and they're just common sense. But hopefully you recognize that they distributed the 4. So this is distributive property. Okay. From here to here, what did they do? They just combined like terms. They simplified. That's fine. Okay, so I'm just going to put simplify. Okay. And from here to here, they subtracted 2 on both sides. So subtraction, property. And finally, they divided. So division. Oops. Oh, man. Okay. Here we go. Alright, so that's all I have for notes. What you need to do now is come see me for the worksheet, and I just want you to do the front side, okay? I believe it's numbers 1 through 9. It's it'll say geometry review on it, 2.5 to 2.6. Okay, the first part on 1 through 8, you just list the property, and number 9 has a proof, and I just want you to try it. Don't freak out, okay, because I'm going to actually teach a lot more one-on-one next time. But I just wanted to get you guys a head start on this because I think that you're perfectly capable of doing this on your own. So I hope that helped, and y'all come back now.